Question 2. So for part 1, working out the speed of the particle, well, this is fairly straightforward. We've got an initial speed of 7. We're projecting it upwards, so we're fighting against gravity, so our acceleration is minus 9.8, and we're travelling for 0.4 seconds. So using v equals u plus at, we can work out that our final speed is 3.08 meters per second. Now we've also got to work out the distance above the ground, so using s equals u plus v times t over 2 and substituting in, we can work out that the distance above the ground is 2.016 meters. Now for part 2, you've got to be careful. It says find the total difference travelled by the particle in the first 0.9 seconds after projection. So you can't just use s equals ut plus half at squared, because that will give you the net distance travelled, but we don't just want to know the net distance travelled, we need to know the total difference, so the total distance travelled up and then the total distance travelled down. So let's break that into 2. So for the journey travelling up, which I'm calling S1, well, this is really similar to what we did before. So we've got an initial speed of 7. At the top of the bounce, effectively, our speed is 0, just as we turn to come back down. So v equals 0. Again, acceleration is minus gravity, so minus 9.8. So substituting into v squared equals u squared plus 2as, we can see the distance travelled up is 5 over 2 meters. Now we're going to really need to now focus on the distance travelled down, so we're going to need to know for how long it travelled down. So in order to do that, we need to start off by working how long the journey upwards took. So just again using s equals u plus v times t over 2 and substituting in, we can work out that the time for the journey upwards was 5 over 7 seconds. 5 over 7 seconds. Now we're told that the total time is 0.9 seconds, so the journey time down is going to be 0.9 less the 5.7 seconds travelling up, which is 13 over 70. So that's the time spent on the downward journey. Now we know our initial speed is going to be 0. We're now travelling downwards, so we're going with gravity, so our acceleration is 9.8. So using s equals ut plus half at squared, we can work out the s2, so the distance of the journey downwards is 0.169 meters. So the total distance up plus the total distance down, s1 plus s2, gives us 2.669 meters.